So let me zoom in. Similarity transformations. I'm going to have chapter 7, lesson 2. I'm going to have 2 triangles, and I'm going to maybe enlarge it or shrink it, and then maybe like shift it to the right and then down, or I could rotate it 90 degrees. I can do all sorts of things, but we need to refresh our brains on a composition. Okay, so I'm going to use the number 1. Remember, the open circle is the symbol for translations. Here's how you read this. Okay, ready? Okay. The dilation with scale factor of 2 of a translation 5 units to the right and 1 unit up of triangle ABC. This is number 1 right here. So again, the dilation with scale factor 2 of, so I'm dilating of this. So the translation comes first. I'm dilating it off of the translation. I dilate off of or from the translation. Okay. The dilation, there you go. The dilation with a scale factor 2 of a translation 5 units to the right and 1 unit up. So really and truly the arrow, remember this? We did this a month, maybe November, honestly. So you're working, because I did a dilation based off of this translation, 5 to the right and 1 up. The translation movement comes first, okay? So I'm gonna do, my math is going to be, I need blue and pink. Okay. Oh, something else that I need to add. This symbol, it's like a congruent symbol, but it's only got one of the lines, means similar. We're going to spend a lot of time in chapter 7 talking about similar triangles. And this one is similar shapes that are translated. Okay. A dilation of 2 means it's doubled. This T means 5 to the right, 1 up. Okay. So here we go. My original shape is there, and we have lots of time. Yeah, we do. I have 30 minutes. Okay. I'm going to first translate 5 to the right. So -6 plus 5, comma, 1 plus 1. -1, 2. -2 plus 5, comma, 3 plus 1. 3, comma, 4. Right? I'm going from my original. The X value is 5 to the right. The Y value is 1 up. Some teachers write it like this. Maybe you like this. The X value is 5 up and the Y value is 1 up. I've seen math teachers do this. Maybe you like this. And if you do, then this is the way that you should remember. Okay. So last ordered pair, C. -2 is my X. -2 plus 5, 1 plus 1. 3, comma, 2. I'm not going to draw every single movement on this, but I will draw this one. I will draw the pencil first, and then I'll draw the blue, and then before I do red. Okay. Pencil. -6, 1. -2, 3. A. Maybe I should use a mechanical pencil for this. B. Ooh, so small. C. -2, 1. Okay. A, B, C. A, B, C. Easy as 1, 2, 3. All right. Blue is my translation. Now, I could say from every dot, go 5 to the right and 1 up and just go dot by dot. Or I could just graph my order pairs. So if you want to do it by using pictures alone, you would just say point A, count 5 to the right and 1 up. 1, 2, 3, 4, 5, 1 up. Hey, is that -1, 2? Sure is. -1, 2, what I put down. B, 3, 4. This is really like B prime, you know. C, 3, 2. So I translated 5 to the right and 1 up, and it's the blue. Now, double times 2. Every ordered pair gets doubled. -1 times 2. I'm thinking you could do this in your head. Can you guys do this in your head? I got -1, 2 became -2, 4. 3, 4 became 6, 8. 3, 2 became 6, 4. And at this point, it's literally like A double prime, B double prime, C double prime, because there you go. All right, doubling it, like the whole shape, the sides of the legs, because this is a right triangle. So the sides of the legs are going to be doubled in size. Their length will be doubled. The angle measurements stay the same. In similarity, angle measurements stay the same. Okay? So my red, -2, 4. B, 6, 8. C, 6, 4. Okay. There we go. Can I show you something that's super important? When there's no origin or center of dilation shown, it's the 0, 0. When it doesn't tell you where the center of dilation is, it's 0, 0. And I want you to notice that when I go from the origin, it's going to be directly all lined up. See this? Okay. So what I did is I was able to draw lines from the origin and say it passes through the blue and it passes through the red. It's obviously not going to pass through the pencil because I shifted the pencil first and then I enlarged it. Okay. But from the origin, that's my center of dilation. 0, 0 is my center of dilation. Okay. Questions?
So 0, 0 is the center of dilation because it passes through the red image and the blue image.
Yes, and when it's not told to you in the math problem where the center of dilation is, you always assume it's the origin.
Okay, thank you.
It might tell you the center of dilation is -5, -8. And so like this dot down here would be the center of dilation. But then you would be informed of that. And then everything from the center of dilation would be like shoot off of it. Like, okay, well, look at my face, not my hands. The image would like have rays that would connect. You know how when I'm talking about like dilating a shape, yesterday's notes had it really good, where it was like one triangle enlarged into the next triangle and you could see how it just got bigger. It's like a flashlight. If I had a flashlight that had a triangular lens, you would start with a small triangle and then you'd get bigger as the ray of light enlarges. So that's what a dilation is. Or a spotlight that's shining in the sky from like some big attraction. It's a small circle when you look on the ground level at the spotlight. When you're looking up in the sky, it's this giant circle that looks like it's, like 100 feet in diameter. That's how a dilation works. All right. Next, we are going to readdress rotation of 90 degrees. The rotation of 90 degrees is going to be the ordered pair negative y comma x. So this is just, by the way, this is a little ray. It's just a little like small bar, little -6, 2, 2, 2. Okay. C, I'm supposed to use my mechanical. D. Okay, this is bar. If I'm going to rotate it 90 degrees, we have the ordered pairs, which we talked about. And this was definitely, let's see, blue and red. Okay. Change the y value and make it negative. -2, and it goes in front, and the x value stays the same and it goes second. The y value is negative and change, keep the x value as that same. Let me graph that. -2, -6. -2, 2. And you can see it. Man, that tracing paper is like valuable stuff. And I, of course, because we did it, what, in September or something ridiculous far away, along October. I don't have any tracing paper left. But as you can see how the pencil got rotated, I know that it looks like you're going counterclockwise, but it's when there's that difference between saying the words rotate clockwise versus the 90 degrees, which is the backwards movement. That was something we talked about during rotations. So like when I say rotate clockwise in words, that's when I go like this order, right? Clockwise. I rotate a shape that direction. But since I'm doing in the notation, in the rotation notation, it actually does go the opposite direction. You just memorize the order pairs and the tricks to the order pairs. Now I'm going to do red, dilate by a half. Shrink this blue line in half. I want half the value for my ordered pair, half of -2. And class, what's half of -6? Just shout it out so we can get through notes.
-3.
Half of -2. Half of 2. -1, -3. -1, 1. So you can see how the blue line shrunk to become the red line. Okay. I've got to move on. I've got to move on.
Miss Grant,
Yeah.
what's like the center of origin for? Like, what is it used for?
If it tells you, we don't do it in this math book, but there are times when it says a shape is enlarged by a scale factor of 3. Draw the image using the center of dilation at the origin. So I would have the origin be my center of dilation. I would have this triangle with ordered pairs, and then I'd have to double it from the origin, and you'd have to do the math yourself of like where it would be located if I doubled this triangle. So it's like a word problem.
Miss Grant, shouldn't the blue line be one more to the left?
I don't know. Why?
Because it's -2 instead of -1.
Oh, no.
Oh, sorry.
No, you're right. I messed up. Darn, that's what happens when your math teacher doesn't know how to count. Yeah. Anyways, okay. Sorry. All right, let's move on. I'm not doing number 3 just due to time. Number 4, how did I get from one thing to the other? Okay, how did I get from one thing to the other? Describe a similarity transformation that maps PQRS to WXYZ. Okay, so what do I want to do first? Well, the big trapezoid needs to turn into the small trapezoid. And based on the way we've been doing things, I'm going to reflect what? Big triangle has to become the small. I first need to reflect how. What's that called? The reflection over the
axis.
Reflection over the y-axis. I use my composition symbol. Now, how do I know what the dilation is? Measure a side. Well, PS. So PS is 1, 2, 3, 4, 5, 6. And then WZ is 2. So I went from 6 to 2. I went from big to small. Am I tripling it, big to small, or am I cutting it into 1/3, big to small? When I go from a large trapezoid to a small trapezoid, am I multiplying by 3 or am I multiplying by 1/3? Big to small.
1/3.
1/3. All right. I'm not going to do 5 just due to the fact that I've got, to move on. I've got more to do. Yeah, I have 12 minutes. Okay. This is review. I think you'll find that this is really nice. Okay. So. Okay. All right, here we go. The ratio of two complementary, 90. Two complementary angles is 3 to 7. Okay, so that means that I'm going to need to do 3x plus 7x. Three times, I do, my pencil just broke off. Okay. 3x plus 7x, the two angles added together make 90. All right, 10x equals 90. We did this before. This is not new to you. But the question asked me not to find the value of x. The question asked me to find the measure of both angles. So I'm going to do 3 times 9 and 7 times 9. 27 and 63 degrees. Those two add up to 90. Number 7, the ratio of the measures of the angles of a triangle, 180, is 4 to 7 to 9. One of them is 4 times the quantity, one of them is 7 times, one of them is 9 times the angle. Written as 4x plus 7x plus 9x equals 180 degrees. Go ahead and solve that on your own. What'd you guys get for x?
9.
9. 4 times 9, 7 times 9, 9 times 9. My angle measurements are 81, 63, and 36. Okay. On the last 4, we're just going to do the easiest one and the hardest one, A and D, because we have literally 8 minutes, and sometimes I keep you all the way to Bell, sometimes I don't. Just depends on the day, right? Cross multiplying, proportions, cross multiplying. 28 equals 2x. Easy. Because 4 over 14 equals 2/7. Yes, it does. And my proportion is correct because my two fractions are equal. On this last one, I have to do a little bit of foiling and then 27 times 5. I actually don't have my 27 memorized. Shame on me, right? 135. 27 times 5 is 135. And then x minus 1, x plus 5. And I FOIL x squared outside inside is 4x minus 5 equals 135. Minus 135. We've had this trinomial before. Someone new, tell me what the parentheses is.
X plus 14, x minus 10.
Yes, x plus 14, x minus 10. Which means I have two values for x, a negative 14 and a positive 10.
Why do we make 14 negative again?
Because when I do x plus 14, I set each value equal to 0. It's called the zero product property. When I solve for x, I have to subtract 14 to both sides to solve. And think about it. If I have this parentheses, something plus 14 equal to 0, only negative 14 makes a 0, right? It's the opposite sign that cancels it out. So there's another way to look at it. You can do zero product property and solve for x, or you can say, what number plus 14 makes 0? If I plugged it into the parentheses, it'd be negative 14 plus 14. That makes 0. Okay. So, your homework is on Pearson. Oh, let me turn off the recording, sorry. Oh, stop recording, sorry.